welcome to my channel Star Middle Kids. Today in this video we are going to discuss about the Aufbau principle. But before going discussing about this Aufbau principle, what we have learned in our previous videos, we have followed a flow chart. Shells, subshells, orbitals. Shells are nothing but these are the part where the electrons revolve, and subshells they are useful to locate these electrons, and orbitals they are used to give the orientation of the electrons. Shells, KLMN, etc. Shells, SPDF, etc. Orbitals 1s, 2s, etc. Just leave about these orbitals. This orbitals how to arrange these orbitals is given in this Aufbau principle. So shells and the subshells. KLMN are the shells. In this we are having the SPDF. In K only S we are having, and in LM LSP we are having, and in M S P D we are having, and NSPDF. So N contains all these four. M contains only these first three, L contains first two, K contains only S. But we further extend these stub shells to the orbitals, which are nothing but the 1s, 2s, and etc. But for what are these orbitals required, and what is the connection with the Aufbau principle? 1s, 2s orbitals, while writing about the electronic configuration, which will help furthermore while determining the alkaline groups and 1a and 2a, etc., etc. By these orbitals and the link between the Aufbau principle, we can definitely write the electronic configuration and find the exact value. These orbitals are required for writing the electronic configuration with the link of the Aufbau principle and with the help of the Euler's diagram. Orbitals, Aufbau principle, Euler's diagram relate with each other and produce an excellent output, that is electronic configuration. These orbitals, Aufbau principle, Euler's diagram correlate with each other and form the electronic configuration. And the electronic configuration can be used to determine various things. But for example, when we are discussing about the chapter like atomic structure, it is mainly useful for determining the valence shells, valence electrons. And while discussing about the bonds even too, this will be very helpful. That is, if you want to find the bond, how the bond, that means how many electrons are shared in the NaCl. Is it how many electrons are shared? What is the valency of sodium? What is the valency of chlorine? No need to by heart this, because electronic configuration, if we learn it perfectly, we can definitely say the electronic configuration by just practicing. And this electronic configuration helps us to know that even we can form the bond very easily, and even it is helpful for the Lewis dot structure. It is also for Lewis dot structure. When we are asked to draw a bond between NaCl or H2O, we need not worry, because this electronic configuration will help us much. But before going to the drawing of the bonds of these like simple compounds like sodium, water, potassium sulfate, and etc., we need to know the electronic configuration of the respective element. So on knowing this, we can directly know the valency of sodium, chlorine, and easily draw the bond. And very useful, this electronic configuration brought from orbitals, Aufbau principle, Euler's diagram. So what is Aufbau principle and how it is related with the Euler's diagram? And what is the relation between these three, and how to write the electronic configuration. And after that, I am gonna teach about the Lewis dot structure and how to write it, and the valence electrons, how to find it, and valency, etc. So in that today's video, we are gonna discuss about the Aufbau principle, Euler's diagram with the correlation with orbitals, and configuration in the further videos. So This Aufbau's principle we are going to discuss now. Aufbau's principle. I'm just going to say what is the principle. This is the statement, this is a rough statement given as the Aufbau's principle. The electrons always fill up the orbitals. These electrons fill up the orbitals in which way? In the increasing n plus L value of the orbital. Increasing means from the small towards the big. This is towards the large. From the small n plus L value to the large n plus L value. What is this n plus L value? We will be discussing, but we can just generalize this statement. The electrons always fill up the orbitals. In which way? In the increasing order or the value of n plus L of the orbital. We have discussed that orbitals 1s, 2s, etc. For this, if the n plus L value for let's just take that 1s n plus L value is less than 2s n plus L value. Means first the electrons will fill the n 1s and then it will go to 2s. That is the statement that I have explained with an example. It states that, for example, let us consider the 1s n plus L value is less than the 2s n plus L value. Then the electrons will first fill the 1s orbital and next the 2s orbital. This statement means this, from this example we can understand this statement. So on the basis of the n plus L value which has small, it fills first, and on that which has large will be filled next after the first. That is, we have discussed in the example. 1s is less than, let us consider. We are not generalizing the statement, let us consider. 1s is less than 2s means then the n plus L value of 1s is less than 2s means it will first fill 1s and then after the 2s. Let us find out the n plus L values. What is n? What is n? So we are now going to discuss about the n plus L value. What is this n plus L value? N. From the second video, we have learned that principal quantum number is represented by the number n and L azimuthal. How to find this n plus L value of a certain orbital? Let us consider to be something like easy, like 1s. 1s orbital, let us consider. How to find the n plus L value of a 1s orbital? For principal quantum number, it is to find the principal quantum number, it is very easy. This is the subshell. The number before it may be 2, 3, 4 or infinite. This is the principal quantum number value. So we have got 1 plus what is the L value? While discussing about the azimuthal quantum number, I have given certain L values of the subshells. S0, P1, D2, F3, so on. S, P, D, F on the increasing order. So from this data, we would find that S equals to 0. So the n plus L value of 1s is 1. I think so you have remembered this table. S is 0, P is 1, D is 2, F is 3 and so on. G is 4 and so on. So the 1s has a n plus L value of 1. Can we say that is this absolute, that it is to find that the 1s is the smaller, or it is comparative? It is always comparative, because by seeing this 1s, can we say that it is small? Because we might have another small orbital. So this n plus L value is always comparative. So let us consider 2s. The principal quantum number value is 2. S is 0. 2. 1 and 2. Comparing the 1s and 2s, we are having the n plus l value to be greater for the 2s. Before we have discussed an example of 1s is always less than 2s. So this proves that statement. The n plus l value of the 1s and 2s, 1s is always less than 2s is proved by this statement. So the electrons first fill 1s and then the 2s. So the n plus l value, which is comparative, is determined by looking at the orbital and its principal quantum number value and the orbital quantum number value. In this way we can fill the electrons. And how many electrons will fill in this, or p or d or f or etc. Before going into that, let us do another example. Let us consider to be 3D. 4f. To be quite complicated, I have took 4f. Principal quantum number value 4. F is 3, 7. This would be somewhat larger value than these two. So the electrons will first fill 1s and 2s and 4f. After discussing about the Euler's diagram, we will know that after 1s and 2s, 4f will not be filled and some other orbital will be filled, but Euler's diagram I am not going to discuss in this video. In the next video, I am going to discuss about the Euler's diagram. So 1s after 2s is not filled by 4f but another orbital. This is just for example. To be quite complicated, the orbital, to make the orbital quite complicated and make you to understand the concept, I have just took 4f, which is quite complicated. So 1s is always less than 2s orbital on basis of the n plus l value. On this arrangement of 1s and etc electrons, electronic orbitals, we get the Euler's diagram in which order he has arranged this orbitals. Before going to this, while writing the electronic configuration, we should know how many electrons will fill in S, P, D and F. While discussing about the azimuthal quantum number, I have given also these values. S will have 2, P will have 4, D will have D will have 10, F will have 14, P will have 6. S will have 2, P will have 6, D will have 10, F will have 14. So on basis of this, we got that the S, P, D, F values, and how to represent means for a 1s if it is completely filled 2 or only one electron is filled 1. In this way, on only the orbital it should be filled, not down 2 or like this one. It would become some other, but we should always represent it in this way. So thank you for watching my video. Please subscribe to my channel and share this video to your friends. Thank you.